This is what we like to call in the business an improper integral. What makes it improper is if you substitute a 3 into this function, that's going to give us division by 0. So that doesn't really mean the answer is going to be undefined or infinity. It just means we need to integrate and see what happens. So this one, I think I would use u substitution. So let u be the inside part. The derivative of that would just be 1 times dx. And then we're ready for the u substitution. So when I do u substitution, I leave off the 3 and the 5 because this is what x equals and this is what x equals. It's not what u equals. So for the moment, I'll just leave that off. And then the 2 can stay there, or you could factor out the 2. I think I'll factor out the 2. That would leave a 1 on top. And then it would leave the square root of u on the bottom, and then dx gets replaced with du. So for this one, you could rewrite it as integrate u to a negative 1/2. You like how I made the font a little bit bigger so you could see it better? And then add 1 to the exponent, that's going to be a 1/2, and divide by a 1/2. So when you divide by a 1/2, that means invert and multiply. So actually multiply by a 2. So that's going to leave a 4 in the front. And then this is going to be u to the 1/2, or in other words, the square root of u. And then we took care of this, we took care of this, we took care of this. Because we have numbers to plug in, I'm not going to put a plus c. So I'm going to go back and replace the u with x minus 3, and now evaluate from 3 to 5. So if you substitute the 5, first of all, this is going to become the square root of 2, so 4, and then the square root of 2. Then it goes minus, substitute the 3 in here, but when you put a 3, that's going to be a 0, so it's really going to say minus 4 times 0. And 4 times 0 is not going to contribute to anything, so it turns out that the answer is just 4 square roots of 2.